Okay, heat and temperature tutorial. Let's talk about heat and temperature and just go over some basics about it. All right, so let's go, get into here. There we go. Room temperature. So I've done a few mini lessons showing you boiling water, boiling noodles, and cooking. Just it kind of goes over a couple little things like that. The temperature, degree of hotness or coldness of a body or environment, the measure on of the average kinetic energy of particles. Thermal energy, the total kinetic energy of particles in a specific amount of matter. Heat, transfer of energy from a warmer object to a cooler object. Okay, temperature, it's just showing you at what point. I broke this down even further on a mini lesson, temperature conversion, Kelvin, Celsius, and Fahrenheit, what it is on each scale, so you can see it on there. And I broke down the conversions and showed you how to do all of that on there. But real quick, let's go back to that. As you can see, their temperatures are different. Water freezes at different temperatures, boils at different, absolute zero is different. Absolute zero for Kelvin, you'll see this a lot in chemistry, it will be obviously zero. Thermal energy, total energy of an object has a result of the temperature. It's just, look, it's the result of the temperature here. So where is it the warmest or hottest? The red part would indicate that it is the hottest right there. Internal energy, temperature measured only the translational kinetic energy possessed by the particles in the object. Okay. So then let's get into heat and show you what's next. And heat transfers from hot to cold. Not really a physical property though, but it's just good to know what's in there. Now, here, let's just review the definitions. Heat would be a transfer of energy between objects, and then internal energy, total combined energy of all particles, thermal energy, total translational kinetic energy of all particles, temperature, average translational kinetic energy. Okay, states of matter. Let's see if this, okay. States of matter, let's click on this. It'll show you an example. So here, obviously this is a solid because they're all grouped really closely together. Liquid, they're moving around the container because a liquid would take shape of the container, as you can see. Gas, they're all over the place, like all throughout the air. Again, solid, liquid, gas. Okay, let's go next. And again, it just shows you the different particles. I've done this before too with the mini lesson, and let's see what else we have here. Potential energy. Energy possessed by an object as a result of its internal state or its position with respect to other objects. Internal energy, all energy possessed by the particles within an object, not counting energy possessed by objects as a whole, okay? So this is just showing again, solid, liquid, gas, how it goes back and forth between the states. Okay, heat capacity, ratio of the amount of heat transferred to an object and the resultant change in temperature. Specific heat capacity, the amount of heat required to raise the temperature of 1 gram by 1 degree of Celsius. So that's specific to whatever object it is. So we'll read this again. A specific heat capacity, the heat that must be absorbed or released to change a substance by 1 degree Celsius per unit of mass. Calculating temperature. Okay, this just goes over a couple equations and stuff like this. Okay, gives you a couple other equations. Combining materials. Okay, kinetic energy. Energy of motion in a body. Open, closed, and isolated just shows heat transfer, mass transfer. Closed would be heat transfer, no mass transfer. Isolated would be no heat transfer, no mass transfer. Okay, open systems exchange matter and energy within the environment, a cup of tea from which steam and heat escape into the air. Closed system exchange energy but not matter within the environment. Isolated, they don't exchange matter or energy within the environment. Okay, so again, let's review these. Isolated system, a closed, thickly insulated metal container, so like a metal water bottle, metal container, something like that. Closed system, a balloon filled with air left out of the sun. Open system would be a campfire in a forest. Radiate, transfer of heat by emission and absorption of electromagnetic waves. Conduction, transfer of heat within an object or between two objects that are touching. Gives you a couple examples. This would just show you gas properties. Ideal gas properties. So let's just take a look. Add particles. And we just watch what they do. So it just shows you a couple examples. Okay, this just kind of goes over a couple of things. Just shows you a few other things here. Okay, this gives you a couple equations. Hopefully that clears it up, gives you a little bit better understanding.